Smart solar power conversion. The sun, which serves as a source of renewable energy, emits both light and heat energy. Generally, we use photovoltaic cells to utilize only the light energy to produce electricity. But more amount of heat energy is dissipated both from the sun and the solar panel, which can be utilized with the help of thermocouple. But the disadvantage is thermocouple produces only millivoltage. To overcome this, we use Fresnel lens, cold compensation and amplifier design. Here, this is a thermopile whose leads are connected in series. Hence, we can get multiple output. In order to increase the hot junction of thermopile, we use a Fresnel lens setup in which we can increase the emission up to 800 degrees Celsius approximately. Hence, increasing the junction temperature correspondingly increases the output voltage. Also, we can give it to an amplifier circuit. Here, we have a comparative setup to analyze the efficiency of thermocouple and photovoltaic cell. First, let's enter into the photovoltaic cell section. The photovoltaic cell section consists of two photovoltaic cells of 6 volt and 0.8 amp. The solar cells are made up of silicon. It is a natural element which gets electrically polarized when exposed to sunlight. The panels are connected in series, which produces 12 volt and 1.6 amp. The output of the solar panel is given to the charge controller of 12 volt and 10 amps. The charge controller ensures safe charging of the battery. The first two pins are from the solar panel, the second pins are used to charge the rechargeable battery, and the 4 pins are used to connect the loads. Here we use an LED drive. Charge controller, the MOSFET is used as main switching element, and the other transistor act as auxiliary switching element. Here the two LEDs are used to indicate charging, overcharging and short circuit. Now the LEDs indicate that the battery is low. Also here we shown the rechargeable battery which has a capacity of 6 volt and 4.5 amps. Next, let's move on to the thermocouple section. In the thermocouple section, we have 5 J-type thermocouple which forms a thermopile setup. The hot junction of 5 thermocouple are brought together to form a single focusing point. To increase the temperature of measuring junction, we have chosen a Fresnel lens. The Fresnel lens have concentric structure which converges the light beam into the focusing point. The temperature can be increased up to 400 degrees Celsius approximately. We have also developed a single axis tracking system. Thereby, we placed 2 LDRs on the 2 corners of Fresnel lens. The LDR senses the light intensity and produces change in resistance that is given to signal conditioning unit and given to the amplifier LM339. The amplifier output is given to the PIC microcontroller. The PIC microcontroller is pre-programmed to generate zeros and ones that determines the direction of tracking. The output from the PIC is given to the quadrupole half driver L293D, which is used to drive the geared motor to track the sun's position. The rated speed of the geared motor is 3 RPM. The transistor used here acts as a switching element. The transistor plays a major role in driving the motor in both the directions. Since the tracking setup is placed inside a room, let's see a manual operation of the working.
The sunlight fall on the Fresnel lens is focused to the hot junction of thermopile. It generates the output in the range of millivolt. In order to amplify the output, we have given the output to the amplifier circuit. Here, this is the input to the amplifier circuit. We used the operational amplifier LM741 of Texas Instruments. This 2 resistor determines the gain value. We used 30 kilo ohm and 100 ohm resistor. Hence, the gain of amplifier is 3000. Next, IC LM35 act as the cold compensation circuit for the thermocouple. Change in degree Celsius produces 10 millivolt. Hence, we get the maximum output as possible. Next, we move on to the filter and rectifier section. These two capacitors and set of diodes act as the filter and rectifier. We used LM741 as the amplifier because it has high precision value. The output from the amplifier is given to the charge controller of 12 volt and 10 amps. It is same as we discussed earlier. Its output is given to the battery of 6 volt and 4.5 amps. Next we move on to the load setup. The load contains a set of 8 LEDs of each 1.2 volt and 20 milliamps. These are connected to the LED driver TLC5940NT of Texas Instruments. The voltage from the charge controller is given to the V2I converter. This converts the input voltage to current. It is designed with Texas IC LM741. The current is given as an input to PIC microcontroller 16F877A. The PIC is interfaced with 16x2 character LCD to display the voltage and current produced by the two setup. Here it displays the voltage and current.
Our hardware implementation setup. Here, the output from the solar panel is controlled by the charge controller and it is given to the battery. The solar panel output is given to V2I converter and the output current is fed to the PIC microcontroller. The PIC microcontroller is interfaced with the LCD display to display the current and voltage. This is our thermocouple and Fresnel setup. The thermocouple output is in the millivolt. It is amplified by LM741. The IC is powered by a 12 volt panel. The amplified output is given to a charge controller to charge the battery. The voltage produced from the thermocouple amplifier is converted to current with the help of V2I converter. The V2I converter output is given to the PIC microcontroller. The voltage and current of the thermocouple is displayed with the help of LCD. Hence, from the comparative setup, we can analyze that the heat energy can also be utilized to generate the electricity. We are the team members and we sincerely thank Mr. K. Vijay Kumar for being helpful until the last part of the project. Also, we thank Dr. V. Ranganathan for giving us the background idea and supporting us. Finally, we would like to thank the entire TIADC team and we especially thank Dr. C.P. Ravikumar and Mr. Vaibhav Oswal for their kind support and encouragement.